MechAFlux Standard is a general software for initiation to fluid mechanics. It is an applied toolbox allowing the calculation of drag losses, lift, and many other common functions, covering the basic problems that can be encountered when carrying out projects related to fluids. MechAFlux Standard is composed of 4 main tabs and a series of tools accessible in the Tools menu. Since the calculation of pressure drops is one of the main problems of fluid mechanics encountered in design offices, this software has 3 tabs dedicated to the calculation of pressure drops and fluid networks. The first and the second tab are dedicated to the calculation of regular and singular pressure drops. So we have an ergonomic interface to simply enter the parameters. For example, we enter a duct diameter here of 100 mm. The volume flow, we enter 10 cubic meters per hour. A pipe length 100 meters. And we just have to choose a fluid. We select a liquid or a gas in a fluids editor. So we can make calculations of pressure drop, aerolic or hydraulic. If we take water at 20 degrees, we use this fluid. The viscosity fills automatically, we select the pipe material, here stainless steel. And we can start calculating the head loss. A results sheet. To create a calculation note file, for example, can be saved and printed. We find a synthesis of the results in the pressure drop interface. We also have the accumulation of the results of each calculated element, which can be added to an inventory, here, which shows the calculation lines, which add up the pressure drops, in order to create, for example, a section made up of several elements. We will see here, for example, in the tab of singular head losses. If you want to add a 90-degree elbow, 300 mm, radius of curvature with a diameter of 200 mm. Diameter 100 mm, so we stay in 100 mm, we calculate the pressure drop. The detailed results sheet appears, and in the inventory, we have one more line with this elbow, and the accumulation of pressure losses which can be seen at the top. We can use this accumulation of pressure drops to estimate the power of a pump. We find the accumulation of pressure drops here in a pump system, which should, for example, circulate a fluid in pipes, accumulating these pressure drops. We have entered a suction and discharge height, which make an overall height of 2 meters of elevation. We have entered an NPSH, to check for possible cavitation. We enter the approximate efficiency, and we get the absorbed power. A parameter is missing, we enter the flow rate of 10 cubic meters per hour. So we see the absorbed power, and the useful power of the system. We are going to see the 4th tab intended for the calculation of drag and lift. This tab covers external fluid situations, like objects immersed in a current of fluid. So, for example, calculate the force produced by a current of fluid. Water at 10 degrees, at 10 kilometers per hour, on a 1 meter sphere. The software calculates the force that will be applied to this sphere in this fluid stream. In this profile drag and lift calculation tab, we have 2 main types of profiles. Profiles with drag only. These are classic geometric profiles, which allow us to calculate all the problems encountered. We can also calculate the drag on car-type vehicles. So several basic shapes depending on ACX. So we also have other forms. For example, a parachute, the drag force on a tree. 5 meters wide, in a wind of 100 kilometers per hour. What does it give? That gives 700 kilos of thrust on all the foliage. So we can estimate the resistance of a tree trunk. Where there are, for example, classic shapes, which would give us, for example, here, the thrust that must be produced the propellers of a zeppelin. For these basic shapes, only the resistance drag, air or water, is studied. Depending on the fluid chosen here, and the speed chosen here. We also have profiles with drag and lift, which are therefore aerodynamic or hydrodynamic profiles. We have around 10 different shapes, wing profiles, foils or other flying objects. We also have the possibility of calculating the drag and the lift on an oblique plate. We enter width and length, the incidence, the speed of the fluid, and we obtain the drag and lift. If these different profiles are not enough, we have a profile editor, which allows us to create tailor-made profiles. For example, here with a NACA editor, where we will choose the thickness and the camber, and we can launch the polar calculation with X-foil, and use the result to calculate a wing, the length and width of which we dimension here. So that's it for the drags and lifts of the profiles. And we will now see the tools available in the Tools menu of MechAFlux. A classic fluid mechanics tool, Bernoulli's Maps. This interface uses Bernoulli's equation and shows the energy balance between 2 points of a fluid stream. So we have the first point here, and the second point here. By entering the parameters of the first point, and the parameters of the second point, and by selecting the desired result, we will obtain results. Here, let's say for example, that we have a pressure of 200,000 pascals. So twice the atmospheric pressure, and that at the exit here we have a pressure of 100,000 pascals. So atmospheric pressure, no altitude delta and a speed from 0. The desired result being the speed at the exit, so it will be for example the ejection speed of a pressurized tank, with a pressure delta between the inside and the outside of 100,000 pascals. So we select calculate speed. And there we have the speed that is updated here in the results. So we will have a speed of 14 meters per second with this fluid. So with its density indicated here by applying Bernoulli's equation. Among the tools we have converters, classic, between different units. We have a converter of normals per cubic meter, and of normals per cubic meter hours, according to the different standards. That's quite practical when you have specifications given in fluid mass flow rate, whereas in the calculation of pressure drops, volume flow rates are always used. We have a pipe sizing tool, which allows us to quickly choose a pipe diameter based on the flow rate. For example, here for water, we will enter 100 cubic meters hour. We choose a series of commercial tubes, and we click on Find the diameter. This line loss search function for the given flow diagnoses quickly the type of duct to be used. In the calculation of head losses, for example, it is enough to select the line which interests us, to inject it directly in the calculation of the losses of load. Another tool, the Venturi tube. Depending on the nature of a fluid, its flow rate and the sections crossed, the depression generated can be observed, or depending on a desired depression, the speed required in the parts of the Venturi tube can be determined to generate this depression. We have the tank drain tool. That's a pretty handy tool to know. emptying times, speeds and flow rates from a tank under pressure or with a certain head height. We also have a tool that allows you to size the flues, depending on burner power and air access. So we have the diameters of the ducts, which are given according to the heights and the powers of the generator. We can use this application to estimate the dimensions of flues for oil or gas generators, or with known excesses, such as wood stoves or fireplaces. We see the interface in its basic configuration, but there are many optional parameters, which can be entered for detailed study, with for example the taking into account of the cooling of the duct. Another useful tool is graphical analysis. The graphical analysis allows us to edit graphs of pressure drops, depending on the flow ranges. For example, for the network we have built, we can edit a pressure drop curve between 0 and 100 cubic meters hours. So I run the graphical analysis, and we see the pressure drops following the evolution of the flow. This pie chart shows us, for example, that the two straight pipes of 100 meters generate pressure drops which cover all the pressure drops of the system. Here an evolution of the pressure drops according to the flow. This graph highlights either the load losses, the power consumed in watts, and the cost of the annual load loss, depending on the parameters entered in this area, in terms of operating cost, number of hours per day, and price per kilowatt hour. So this graphical analysis tool also has an extension where we can determine operating points of pumps or reservoirs. And we will say, for example, that our network is connected to a tank with a height of 5 meters, and therefore a 100 millimeters hole for our 100 millimeters pipe. We create the tank curve, and we will test the operating point, and we see that we have a flow rate of 45 cubic meters per hour. If we had a water tower of 5 meters high, connected to our small section which is sized here, we can have a more complete analysis and graph if we wanted to edit a file, for example. So much for this tool for calculating pump operating points. Accessible in the inventory, pressure drops. Inventories can be saved and edited in .csv format, spreadsheets. This is the end of this quick presentation of standard Mecaflux.